Hello everyone, welcome to a new section. In this section, I am here to discuss about non-conventional energy sources. As compared to conventional energy sources, in non-conventional energy sources, the power generation is in small capacity over a short interval of time. For example, wind energy, solar energy, tidal, geothermal, diesel, and so on. Most of the plants are located near to consumer premises and the plants are operated based on day-to-day weather constraints and having less fixed cost and high running cost. Most of the plants are designed to meet peak load demands except geothermal plants. Asynchronous generators are employed for this plan. For example, induction generator, DC generator, and AC generator. Generator voltage will be less than or equal to 11 kV. So, let's discuss about the solar energy. Let's move to the technologies that are being developed for conversion of solar energy to the electrical form. In one technology, collectors with concentrators are employed to achieve temperatures high enough, that is 700 degrees Celsius, to operate heat engine at reasonable efficiency to generate electricity. Some of the applications are the solar power tower generates steam for electricity production. Second, the solar pond by using a special low temperature heat engine coupled to an electric generator generates electricity. So let's discuss the another technology, that is photovoltaic generation, that is direct conversion to electricity. This technology converts solar energy to the electrical form by means of silicon wafer photoelectric cells known as solar cells. The main disadvantage is the cost and maintenance of solar cells, but the solar energy is basically free of cost. In all solar thermal schemes, storage is necessary because of the fluctuating nature of sun's energy. In solar cells, electrons are liberated from the surface of a body when light is incident on it. It is known that if an N-type semiconductor is brought in contact with a P-type material, a contact potential difference is set up at the junction due to diffusion of electrons. When the p-type materials is exposed to light, its electrons get excited by the photons of light and pass into the n-type semiconductor. Thus, an electric current is generated in a closed circuit. So, some of the advantages of the solar energy are: first one, free of cost; second one, non-exhaustible; third one, pollution free. Then let's discuss the disadvantages of power plant. First one is that energy density per unit area is very low. So let's move to wind power. In wind power stations, wind pressure rotates the wind vanes or propellers attached to a shaft. The revolving shaft rotates the rotor of a generator through a mechanism of gears, coupling, etc. Thus, electricity is generated. For wind power generation, there are three types of operations. First one, small, 0.5 to 10 kilowatts for isolated single premises. Second one, medium, 10 to 100 kilowatts for communities. Third one, large, that is 1.5 megawatts for connection to the grid. The theoretical power in a wind stream is given by P is equal to 0.5 into rho into A into V cube watts, where rho is the density of air, V is the mean air velocity, which is given in meter per second, and A is equal to swept area, that is in meter square. There are some distinctive energy end-use features of wind power systems. Most wind power sites are in remote rural, island, or marine areas. Rural grid systems are likely to be weak in these areas since they carry relatively low voltage supplies. Example, 33 kV. Third one, there are always periods without wind. So next, let's discuss about the advantages. First one, plentiful; second one, inexhaustible; third one, non-polluting; and fourth one, it does not impose extra heat burden on the environment. Then some of the disadvantages are non-steady and undependable. So let's move to geothermal power plants. The Earth's interior is made of a hot fluid called magma. The outer crust of the earth has an average thickness of 32 km and below that is the magma. The average increase in temperature with depth of the earth is 1 degree Celsius for every 35 to 40 meter depth. At a depth of 3 to 4 kilometers, water boils up, and at a depth of about 15 kilometers, the temperature is in the range of 1000 degrees Celsius to 1200 degrees Celsius. If the magma found its way through the weak spots of the Earth's crust, it results into a volcano. At times, due to certain reasons, the surface water penetrates into the crust. It results into a volcano. At times, due to certain reasons, the surface water penetrates into the crust, where it turns into steam due to intense heat and comes out in the form of springs. Molten magma also contains water, which it releases in the form of steam, which could be utilized for electric power generation. So next we can move to wave power. The energy content of sea waves is very high. In India, with several hundreds of kilometers of coastline, a vast source of energy is available. The power in the wave is proportional to the square of the amplitude and to the period of the motion. Therefore, the long period, that is concurrent to 10 seconds, and large amplitude, which is similar to 2 meter, waves are of considerable interest for power generation. So next we can move to magnetohydrodynamic generation. In case of thermal generation of electric energy involves two stages of energy conversion. First one is the heat released by the fuel, which is converted into mechanical energy, and second one is the mechanical energy is then used to rotate the electric generator. In this case, conversion has inherently low efficiency, and also the rotating machine has its associated losses and maintenance problems. So, in magnetohydrodynamic technology, electric energy is directly obtained from the hot gases produced by the combustion of fuel without the need for mechanical moving parts. So, we can reduce the losses. In a magnetohydrodynamic generator, ionized gases, that is electrically conducting gas at a very high temperature of 2500 degrees Celsius, is passed in a strong magnetic field, thereby EMF is induced, and which can be collected at respective electrodes. The conducting gas is obtained by burning a fuel and injecting a seeding material such as potassium carbonate in the products of combustion. Then next we can move to ocean thermal energy conversion or OTEC. Do you know what is the world's largest solar collector? Yes, it is ocean. A temperature difference of 20 degrees Celsius between warm solar absorbing surface water and cooler bottom water can occur. OTEC refers to the conversion of some of the thermal energy into work and hence into electricity. Then now we can discuss about the energy storage. Storage of electricity in large quantities creates a lot of problems. Some of the methods are described in brief. First one, secondary batteries. The most widely used storage battery is the lead acid battery. These are used for battery powered vehicles and local fluctuating energy sources such as windmills, solar, etc. Then second, fuel cells. A fuel cells converts chemical energy of a fuel into electricity directly with no intermediate combustion cycle. The next, hydrogen energy systems. Hydrogen can be used as a medium for energy transmission and storage. Electrolysis is a well established commercial process yielding pure hydrogen. Hey guys, I hope you can follow my videos. Don't forget to share with others, and for more basic knowledge on electrical, keep watching the channel. Thank you and have a nice day.